So I believe that you started with the ECZ chemistry, and they might have introduced you to this thing called chemistry. Chemistry is one of the branches of science which is very helpful, and then it has got also a wide range of application. Other than that, chemistry has got many components that one has to start for it to have one to have a complete understanding of the topic. So from the introduction of chemistry, they told us that chemistry is the branch. It's a branch of science. Remember, science has got also branches. It's a very wide component, but the study of science is studied in these branches. So science is a branch of chemistry, rather, is a branch of science that deals with matter. We should be able to understand what matter is all about. Deals with matter and matter, its properties, and the changes it undergoes. So this is what chemistry is all about. Chemistry is actually the branch of science that deals with matter, its properties, as well as the changes that matter undergoes. These are the three things that you need to understand about chemistry. We will never do anything that makes us divert from the basis of chemistry. Are you understanding what I have just written?
Yes.
Okay. Now, chemistry also has branches. Chemistry also has branches. Just like if you are to look at a tree has got the stem. From a stem, we're going to have branches. Out of those branches, we also have their own subdivisions. Yeah. So science has got branches: biology, physics, chemistry, and within chemistry also, there are also branches that are actually found within the chemistry. Yeah. So now, what are these branches? Do you remember these branches from grade 10 chemistry?
I don't think so, no.
So there is biochemistry, there is the analytical chemistry, there's physical chemistry, there's physical chemistry, there is the inorganic chemistry, and organic chemistry. So we can see that we have a mini branch. Here's what we have. We have a mini branch. So if I'm to use an illustration, we have a tree. This tree is, of course, rooted in the soil, and the tree has got these branches. These branches, we can call them physics, we can call them biology, we can also call them chemistry. And now, these very branches also can subdivide, like I've given an example. So chemistry also subdivides itself into now 5 components. And one of these components is the one that we're going to look at. So there's organic, there's biochemistry, there's physical, there's analytical, and inorganic. So out of this, today we'll just look at this one branch of chemistry, which is called organic chemistry. Organic chemistry. Now, this organic chemistry, what does it involve? So we have a general statement, matter, its properties, and the changes it undergoes. Now here we're going to look at what organic chemistry involves. In as much as matter is involved, in as much as the properties of matter are involved, also the changes that matter undergoes, whether physical or chemical, there is a component or there is an aspect where organic chemistry dwells. So by definition, we can say organic chemistry is the branch. This now is also going to be not a branch of science, but it is going to be a branch of chemistry. It's a branch of chemistry that deals with compounds, containing hydrogen and carbon only. So there are a lot of compounds in chemistry. You can agree with me that there are thousands and thousands of compounds. And when you look at each and every compound that you have in mind, you'll find that each compound has got a unique type of atoms as well as their combinations. Now, among the compounds that we'll be dealing with under organic chemistry, we only want those compounds that contain only hydrogen and carbon atoms only. But you also need to understand that when these compounds which contain hydrogen and carbon only react, they will form other compounds, and these compounds may contain other additional elements. Let me show you what I mean. If there's a compound that contains hydrogen and carbon, when this compound reacts with oxygen, at the end of the day, what we're going to have is a compound that will have now 3 atoms. But for as long as these were made out of these compounds that contain hydrogen and carbon only, we will still study them under organic chemistry. I don't know. Let me not leave you behind. Are you getting something?
Yes.
Mm-hmm. Okay. So,
Sir,
yes,
am I supposed to note these ones down?
you can. I'll still send you these notes in terms of a document. I'll also share the video.
Okay, no problem.
Yeah. Now, these compounds that contain hydrogen and carbon only, they have names. They have names. These compounds are actually called hydrocarbon. And from the look of things, hydrocarbon is something that we can learn from, because hydro is coming from hydrogen, carbon is also coming from carbon. So these compounds that contain hydrogen and carbon atoms, they are actually called hydrocarbons. Hydrocarbon compounds. Now, when these hydrocarbon compounds react, more atoms are added to them, which make them to be called derivatives. We are moving here. So I want you to understand something, that these atoms are able to react. They are very reactive. These compounds, of course, are very reactive. Now, when they react, more other atoms will be added to them. They will no longer be called hydrocarbon compounds because more atoms are added to them. Therefore, we will call them hydrocarbon derivatives. Maybe if I should say that, hydrocarbon derivatives, meaning they are derived from hydrocarbons. I'll give you an example of maize. When you have maize as our hydrocarbon, there are a lot of products that we can get from maize. Yeah, we can actually get mealie meal, where people make shima. Others from mealie meal, they make porridge. Some from mealie meal, they make chwanchu, munkoyo. There are a lot of derivatives that we can actually make from them. So these are the ones we are actually called derivatives. So in simple terms, what I'm saying is when we have hydrocarbon compounds, when they react, what is formed is a derivative. I want you to understand this. That these derivatives, we are not getting them from anywhere far, no. They are just products of hydrocarbons. So when hydrocarbon compounds react, what we form from them are derivatives. You can ask, where you're not clear.
So far, I don't think I have. Oh, wait, sir.
Mm-hmm.
Where do these like come from?
Sorry?
Like the hydrocarbon
Okay. These
derivatives.
compounds, some of them are obtained from plants, others are obtained from animals. Also, there are some that we can actually make in the laboratory. I'll give you an example of natural gas. The natural gas, the gas that they use for making margarine, in certain places, the gas that they get from a sewer system. Do you know that from a sewer system we can obtain the gas that is used for cooking? Oh yes. In case you didn't know, from a sewer system, there's a lot of methane, which is an example of hydrocarbon. There's a lot of methane that we can actually get from a sewer system. And that methane is one of the hydrocarbons that we'll be talking about very soon. Yeah. So that's one thing we need to understand. Now, these hydrocarbons, these compounds are thousands of them. These compounds are thousands. in numbers. Therefore, to study them, we need to put them in groups. We need to put them in their respective groups. Believe you me, when you're given a very big crowd of people to lead, it's a very tough task. In case you actually did not know, it's a very tough task to lead a very large group of people. So the best that you do to yourself is make sure that you put them in small groups. Even in church, when we have a very big congregation, actually the pastor or the preacher will maybe say, I think we can have a women meeting, we can have youth meeting, we can have a marriage meeting, we can have small groups based on the categories that we have, and these ones will be very easy to actually manage. The same applies to organic compounds. We put them in groups and it becomes easy to study these compounds that are in these groups. And these groups are called homologous series. So when you have a class of compounds, a lot of them, and of course these compounds are supposed to show a similar characteristic. They must be similar in one way or the other. That's the only way we can put them in these groups. And these groups are called homologous series. Homologous series. And therefore, when we find these groups, as we study them, how can we know that these elements belong to the same group? How are we going to know that these compounds belong to the same group? So by definition, we'll say that homologous series are just a series of compounds. The homologous series is a series of compounds that have same functional groups and that each consecutive members differ by a CH2 unit. I will explain. We are saying that it's just a series of compounds. Just a series of compounds. And one thing we know for sure about these compounds is that they have the same functional groups. I'll explain these points that I'm actually highlighting. They have the same functional groups. And each consecutive consecutive members differ by a CH2 unit. I want you to tell me what consecutive means. If we say that these are consecutive brothers, what do we actually mean? Or maybe we say these are consecutive siblings. What do we actually mean?
I actually not. I actually don't know what it means.
Maybe try Googling just for a minute.
Okay, let me check.
Consecutive. Mhm.
Following each other. It
Exactly.
says following each other
Exactly.
continuously.
Exactly. So what we are saying is that when we put these elements in their groups, when we put them in their groups, there will be a particular way in which they will be organized. Now, those that will be following each other, the only difference we need to see between them is one carbon and two hydrogen only. Remember from the beginning, we are saying that we are studying mostly compounds that contain hydrogen and carbon. There will be thousands of hydrogen atoms. There will be thousands of carbon atoms. Now, when we compare the two, if I was to use this illustration, if this compound is here, this compound is there. Now, remember they are arranged according to sizes. Yeah, this compound is there all the way up to the end. So if this is the first, this is the second, the third, the fourth, the fifth, and the sixth one, the difference between 1 and 2 is 1 carbon and 2 hydrogen only. Meaning it is very easy to predict all the compounds. Because if we know one compound here, we know it. Then to get to the second one, we just add 1 carbon and 2 hydrogen atoms. To go to the third one, we'll add 1 carbon and 2 hydrogen atoms to the second atom. But moving from the first to the third, we are going to add this and that, so it will be 2 carbon atoms and 4 hydrogen atoms. It is very easy, we can actually predict. Or in simple terms, we could just do this, that we need 1 carbon and 2 hydrogen atoms. 2 of these. We actually need 2 of them. So it's very easy to predict all compounds for as long as you know the first one in the specific homologous series. And that's the beauty of organic chemistry, because it is very easy to understand, because there are very few calculations that are involved, and it is very easy to predict what is coming after. Please ask questions.
Could you please explain
again? I'll go back to,
but in a different way.
In a different way. Good. I'll go back to the age group. Most of the homes, the child spacing that we have is 2 years. Most of them is 2 years. So if this is the firstborn and we have the secondborn, the difference is 2 years. From the second to the third, 2 years. From the third to the fourth, 2 years. The fourth to the fifth, all the way up to the fifth to the sixth. Now, if we know how old the first one is, let's say the first one is 14 years, how old would be the second born? To be 16, right?
Yes.
How old would be the third born? 18. The fourth born?
20.
Okay. Now, in case we forget about this arrangement, please forget about this arrangement. But we know that the firstborn is 14 years old. How can we tell how old the thirdborn is?
By knowing
Uh-huh.
By knowing the difference between
the first and the second, the second and the third.
The first and the second and the second and the third.
Exactly. So if we know that the difference says it's a 2 and a 2, what do? We just add the 4, right?
Yes.
So 14 plus 4, it will definitely give us 18 years. It's now making sense?
Yeah.
Good. So this is what actually happens within the homologous series. Now, what other information can you get from the compounds that are found within the same homologous series? The other information that we can find is this. We can say that members of the same. Now, I don't want you to categorize or to generalize. Remember, different families have got different child spacing. So, are we going to say members of the same family? If there's a particular child spacing age that is used, it must be applied only to that member, to that family. Others have got different years that they have in between. So saying members of the same homologous series. Should we say to the same family? What do we expect of them? A, we expect them to react in a similar way. This is common even in families. They'll be like, you in your family, you look alike. I'm sure you've heard of such sayings, right? You in your family in Nyanja, they say, you look alike. When I saw one, it means I've seen everyone, including your mom, because we belong to the same family. And sometimes, if you hear how the firstborn talks, maybe he stammers, you find that the rest of them will stammer. Sometimes certain families are like that. So in chemistry, what do we say? They obey the general formula. You find that certain families, they have rules that they follow, and everyone has to obey for as long as they belong to that family. So they react in a similar way. Now, why do they react in a similar way? Because the part of the yes. So I was saying, why do they react in a similar way? It is because within the molecules or within the structure of these compounds, they have something which is similar or maybe even the same. So they react in the similar way because they have the same part which makes them react in a similar way because they have the same. Now that part is called the functional group. Just like I would say, if maybe this family stammers, everyone in this family will be stammering because they have something similar in them. It could be that there is a gene which is responsible for their stammering. Maybe they are light skinned, you find that everyone will follow suit. Why? Because they have that gene in them all that makes them look similar. And that gene, for today, we're actually calling it the functional group. However, in as much as that happens, we are saying not only that, these compounds supposed to have the general formula, supposed to have the same functional group, supposed to react in a similar way, and the naming of the members or the names of the members, have the same ending. I'll give an example of a family. If it's a Mlenga family and we have Justina, definitely that would be a Justina Mlenga. If we have Mercy, that would be a Mercy Mlenga. If we have Lisa, that child would be Lisa Mlenga. If you have Jerome, the name would be Jerome Mlenga. If you have Jacqueline, to be Jacqueline Mlenga. The naming of all these members in the family supposed to end in a similar way because they belong to the same family. But we're not saying the same thing happens to them all. No, we may have the Mlenga and the Pupe family. So if the other one is a Pupe family, the naming will end with a Pupe. If you belong to a Mlenga family or maybe to a Mpondela family, the naming has to be with Mpondela because that's a family that you belong to. Am I making some sense?
Yes, yes.
Good. So that is what you need to remember about these function groups. Now, as we wrap up with our first presentation, how do you define a functional group? Anyway, can you look up on the internet and tell me what a functional group is all about?
Okay.
Mhm. What is a functional group? What is it? What
Functional or function?
functional? What is a functional group?
Okay.
Mhm.
Let's see. It says that in organic chemistry, a functional group is a substituent. Substituent is a
Is a
substituent.
substituent. Substituent.
Substituent
Mhm.
or mo moiety. Moiety.
Or what?
I'm not sure. I'm not sure on how to pronounce it actually.
Could you maybe spell it out? Uh-huh.
Um, okay, I wanted to share my screen, but I'll spell it. Moiety.
Moiety.
Yes, ETY.
Moet.
Yes, in a molecule that causes the molecule's characteristic chemical reactions. That's it.
Okay. So that is how you have defined it, that it's a substituent or moiety in a molecule that give its chemical characteristic reaction. Now, in a moment, you don't want to say moiety, you can just say the bond. In the moment you don't want to say a substituent, you can say atoms
I
or
found another
group.
definition.
What is it saying?
It says it is a specific group of atoms within a molecule that is responsible
Just a minute.
for characteristic.
Just a minute. It's a specific.
Okay. It's a specific group of atoms with a molecule that is responsible for characteristic chemical reactions for that molecule.
So we are running out of time, but we'll continue. So we are saying that this is the specific group of atoms within the molecule that is responsible for its chemical characteristic. That is very good. So I want you to have this in mind because we are coming back very soon to come and digest on what this part actually means. I'll keep this screen with me because that's where we're actually going to start from. And then you come and understand what everything is actually referring to. But even as much as we wait for, even as we wait for the ending of the session, we only have a few seconds. So we are saying that these substituents could be a specific group of atoms. Now, this specific group of atoms should be attached to the molecule. It should not be separated. If I say in this